Okay, let's look at this starter. We got a negative. It says negative charges are accelerated by electric fields towards points at lower electric potential, at higher electric potential, where the electric field is zero, where the electric field is weaker, where the electric field is stronger. You have, let's just draw an electric field and think about this. And it doesn't have to be a uniform field. Okay, and let's just put an, oh, I'm sorry. Zoom out. So here we have some E field, arbitrary E field. And so we've got some negatively charged particle right there. And it's going to feel a force because it's in an electric field. And that force is going to be in the opposite direction. So this is the electric force. Which means that this thing is going to be accelerated right in the same direction, F equals ma, right? So the acceleration is in the same direction as that electric force, which means it's going to be accelerated in this direction, which means that we are going to be moving against the electric field. And as we accelerate against the electric field, well, not necessarily moving, just accelerating in a direction that is against the electric field. And if it accelerates against the electric field, what's going to be true? What happens as we move against an electric field? Well, it's like climbing a hill. It's like walking up a steep hill. You're gaining potential. And so this is going to, the direction of the acceleration anyway, not its motion, but necessarily its motion, but its acceleration, will be towards a higher potential. So the answer is B. Remember that, and the big idea here is, well, first of all, that the electric force is in the opposite direction for a negatively charged particle than it would be for a positively charged particle. And the other big idea is the acceleration will be in the same direction as the force. And that if you move against any kind of field, if you are moving against any kind of field, whether it's electric field or gravitational field, you're gaining potential. And so that's why it's B. You're certainly not going to move towards a lower potential. So, I mean, A is just wrong. Where the electric field is zero, well, how would this guy has no idea where the electric field is zero. All this guy can do is say, what is the electric field at the point I'm at? And then, and the same is true as it doesn't know where the electric field is weaker or stronger. I mean, here, notice the way I've drawn this. If this thing accelerates to the left, the electric field, the way I've drawn it is getting stronger. But I could have just as easily drawn the field like this, right? Put the electron right there, and here the force is still in this direction, and it's still going to accelerate against the field, so it's going to gain potential. But look, the field is getting weaker. So here the field is getting stronger. Here the field. So I mean, these answers are well, they're wrong. So there's only one correct answer. Any questions? Okay. One thing you can do is, where did I get this book? I got this from, I stole this problem from one of those books on studying for the test. And they have lots of multiple choice questions like this. And by studying that, by getting the right answer, but really studying them, you can get a lot out of it fairly quickly. Yeah?
Electric field lines originate in positive charge.
Well, yeah. The question is,
towards the positive, wouldn't that
No, look, see, that's because there's positive charge over here and there's negative charge over here somewhere. And that's what's causing this electric field.
Yeah.
The electron doesn't know that. This negatively charged particle, well, it knows that. It feels the attraction of these positive charges and the repulsion of these negative charges. I mean, that's what makes the field. Okay. That is all.